Good afternoon, everyone. I hope you had a great lunch, and yeah, it feels very surreal to stand on stage in a real theater in Broadway. It's not something I ever imagined myself doing, but let's see how it goes. I'm going to start by who I am. Some of you here know me, a lot of you don't, I think. I've put a picture up there for you, for those of you who can't see me very well. The first thing that you will notice that I don't really look like that. I think there was a lot of Photoshop involved in that picture. The second thing you'll notice is that that is not a picture of Bjarne Stroustrup, the inventor of C++. He is speaking right now at the same time in stage 3. So if you're in the wrong talk, I'll give you a quick moment to just, leave and go to his talk. Anyone? Can I go? Yeah, so I'm glad all of you stayed. So just a little bit about myself. I come from Cape Town in South Africa. I've been working in the financial industry for 15 plus years. I now live and work in London, and I've done everything from Delphi and ASP through WPF and Flash to HTML5 and React nowadays. Can I just see any Delphi? Anyone who did Delphi in the room? Yay. Those were the good old days. Yeah, I now work at Adaptive Financial Consulting in London, where I've been for about 5 years, and I'm the head of desktop strategy there. And through my time at Adaptive, I worked on several industry-leading desktop platforms for tier 1 banks and other organizations, including Deutsche Bank's Autobahn platform. And I advise clients on desktop technologies, collaboration and workflow, and how they can extract the most value out of that for their organizations. And through doing that, I became involved in FINOS, and more specifically FDC3. And I'm now a program management committee member for FDC3 program and the chair of FDC3's API working group. And I'll say a little bit more about FDC3 later in the talk. But enough about me. Let's talk about what's really important. I think all of us, hopefully, can say that what we want to do is create value for the organizations that we work for. And I got this quote from a VC group called NFX, who specializes in startups and companies with network effects. And they said that over the past 23 years, network effects have accounted for approximately 70% of the value creation in technology. And the study looked at 336 companies from 1994 pretty much to today, with a valuation over $1 billion. And it estimated that about 35% of those companies had network effects at their core, leading to 70% of the value created by those companies. And their conclusion was that network effects have an asymmetric upside. Network effects are what allows companies to punch above their weights, for the Davids to take on the Goliaths. And the study says that the single most predictable attribute of the highest value tech companies is leveraging network effects. So what does network effects mean? It's not actually very complicated. I think most of us here will know that a network is made up of nodes and links between those nodes. The nodes are the network participants, and the links are the connections between the nodes. You can have a high-density network with lots of links between the nodes. You can have a lower density network. You can have nodes that are more important than others, links that are more important than others, but you link all of these pieces together to create value. And what network effects refer to is that basically depending on the characteristics of your network, it starts to scale exponentially in value as you connect more pieces together. As you add more nodes to your network, as you link more of your nodes together, you start to see an upside which is more than just the individual pieces that you're putting into your network. And that is a very powerful effect which scales exponentially over time. And you get a graph which looks a little bit like this. So originally, the network is sort of flat, or the value that the network creates is sort of flat as you're putting the pieces in place. But once you reach a certain critical mass, it really starts to take off. And the value that the network provides scales up almost with the ability to just sit back and watch as the value accumulates from the pieces you've already put in place and each new piece that you add to the network. And there are many different types of networks, physical networks like phone, protocol networks, platforms, data, markets. And they've all got slightly different characteristics and a slightly different point where they reach critical mass. For some it is earlier, for some it is later, but the important point is reaching that stage where you get critical mass and you start to see the value that the network brings to you. Now, one way that in the technology industry we've tried to create lightweight nodes to easily put nodes in place that you can build a network with is through microservices. And each microservice, which is like a standalone piece of functionality, effectively form the nodes in your network. And you then connect these nodes together with standardized communication. In the case of microservices, it's typically HTTP. And I can't stress enough, I think, how important HTTP, which is an open standard, a protocol, has meant for the adoption of microservices. I think if it wasn't for that, it wouldn't have seen the take-up that it has gotten and the success that it has had. And by using the microservice nodes and the standardized communication between them together, it allows systems to be broken down into smaller parts. And there's lots of continued innovation in this area, as we all know. Docker, cloud, open API, the list goes on. But it all comes back down to these lightweight nodes, which are quite simple to create, and the standardized communication patterns between them that are easy for people to adopt. And this type of decoupled architecture brings a lot of advantages that we've seen in the industry. Each lightweight node, each microservice has high maintainability and testability on its own. I've mentioned the standardized communication patterns that allow them to be easily connected. And each piece in the network is independently deployable. So you no longer have to deploy the whole system together. You can deploy them on independent schedules. You can build them with different teams. And it allows the nodes in your network or the microservices to be organized around business capabilities. You can have a team responsible for building the analytics service or the pricing service, and that service can then be used in multiple places, so you avoid duplication in that way. And it allows small autonomous teams that are responsible for individual services or sets of services to work independently from each other and release things at different times, and then they connect it together through the standards. For me, one of the biggest advantages is that it allows evolution of your technology stack. You no longer have a big monolithic systems that you have to bring up to date all in one go, which is costly and very painful. You can, if you break it down enough, you can transfer individual nodes to new technologies or put new ones in place using new technologies without affecting the rest of the system, because they're all still using those standardized communication patterns. And if we wanted to demonstrate this in a diagrammatic manner, when you start a project with a small team, and for a long time in our industry, typically you build things as a monolith. one application with one team that does the front end, the back end, the database, everything else together in one go. And there's a lot of advantages to that. It's easy to deploy, it's one code base. But as systems become more complex, as the amount of people that work on a system becomes more complex, the first thing that happened is systems started to be divided into client-server boundaries. Right? So you have your front-end team working on the front end, the back-end team working on the back end. And that allowed a bit of differentiation and maybe the ability to slightly, at different times, develop those two pieces in different ways. And with the advent of microservices, the back end could then be split up into individual smaller components like your pricing service or your analytics service, which are then aggregated together and used by the front end. But the interesting thing to me about this picture is that the front end here is still monolithic. It's still one front end built by one team that use all of these services. So you don't really get the benefits that we've talked about that exist on the back end if you build it in this way. So where things are now going is that people are starting to talk about micro-frontends. So, whether that means web components, whether it means a widget running on your desktop inside a container like Electron, you have the ability to build smaller front-end components that you can then compose together. They might still go all into one window, but it gives you the ability to also run them separately and combine them as you want with really all of the same advantages that we get on the back end, the independent deployability, smaller teams, evolution of technology. If you've got a big WPF application that you want to migrate, it's very hard to do, but if you start breaking it into smaller pieces and you migrate it one piece at a time, that works much better. But for me, really, the true promise and where we can leverage network effects comes when you can now take each of those applications or micro front-end pieces and start connecting them together into a network. And this is something that a lot of people have not spoken about yet. You're building these individual micro front-ends, but how do you link them together in the same way that you link microservices together with HTTP? Because if you want to build a front-end network from a componentized desktop, enabled by the modern technologies that we've mentioned, how do you define the communication links between those applications? Can we do it in a simple, standardized way inside our organization, but also that spans organizations? Because ultimately what we want to do is leverage the network effect. If we can do it in the same way, using lightweight nodes with simple, standardized communication, then it becomes easy to drop those nodes into place and to scale out over time and get that asymmetric upside. And this is where FDC3 comes in. FDC3 tries to establish open standards for the financial desktop to allow those micro front ends to communicate with each other, to connect the nodes in your network together. FDC3 stands for the Financial Desktop Connectivity and Collaboration Consortium. It was started by OpenFin, a financial desktop platform in 2017. We're also a FINOS member, and they contributed it to FINOS. And the FDC3 1.0 specifications were released in March of this year, and many firms are now starting to use them on their desktops to leverage connections between their applications. If you want to read more about FDC3 than what I say here today, please go to fdc3.finos.org, which explains it all, hopefully in an understandable way. So what are the standards that FDC3 tried to put in place? Well, firstly, you need a way to address applications, to discover applications, so that you can connect them together. And people have tried building app stores or app directories, each in their own way, but if we can standardize that and all do it in the same way, then we can find applications in the same way and hopefully connect them together. Another central piece of FDC3 is the Intense specification. And Intense are a relatively simple concept. They're basically a way to define capabilities that applications have that they can publish in the App Store, which other applications can leverage. FDC3 itself tries to standardize some common intents. An example might be a start chat intent, and one application might say it wants to start a chat. It doesn't care about which application starts the chat, but it wants to transfer the interaction to that application. And that's where intents come into play. View chart would be another example. And if you know a bit of mobile development, intents aren't really a new concept. Android has intents. When you go from your calendar app with a location to your Maps app, that's using an intent to connect the apps together. But what goes hand in hand with that is how do you talk about the data that the applications need to communicate with each other? If you have a start chat intent, how do you describe the contact or the customer that you want to start a chat with? If you want to display a chart with a view chart intent, how do you represent the instrument that you want to display the chart for? And FDC3 defines a standardized way to describe those data payloads that can be used across applications, across the industry. And we work hand in hand with the Financial Object Standardization Group in FINOS to help talk about financial objects in a standardized way when we're connecting applications together. It turns out that contextual data is also very useful for sharing context between applications. If I select a blotter row in this application, my other application can respond in kind because we both know what data we're talking about. And finally, API. A very simple shared set of operations with a low barrier to entry that everybody can use to connect the pieces together. This is all underpinned by the use case working group, which looks at what financial use cases we're trying to solve with these standards and how we can fill the gaps between applications. So let me illustrate it with a very simple example to try and make it practical. Let's say you have an alerting application that shows a notification when a trade was executed. And from that application, you want to start a conversation with the customer. So you can click on the notification, and it takes you to the chat app that knows who the customer is, that automatically launches the chat app, that initiates that conversation, maybe with some context about the trade that you want to talk about. And it all happens automatically with a single click from the user because the applications are connected together. From there, you might want to provide a price to the customer, and it would then transfer into the application that performs the pricing. Now, the key thing is these are all micro-frontends built by different teams independently of one another, but they use the standardized communication to be linked together. And what you will see here is that we've created a network with 3 nodes and 2 links. And this is where the network effect comes in, because now you can put another application in place, add 2 more links, and over time, the amount of things you link together exponentially increases, and the value you get out of your system has that asymmetric upside that we're looking for. So in summary, I've talked about how network effects are critical for unlocking value. Microservices are effectively decoupled HTTP link nodes. And I kind of want to expand the definition of micro-frontends a bit to not just applications that you put on your desktop, but actually linked applications that you can put on your desktop. And an emerging standard that we're trying to create for that is FDC3. It allows us to link applications together. So by doing this, we can leverage the network's effects, and it turns out open connected applications are both powerful inside an individual organization, but also across our industry. Applications from multiple vendors, from the buy side, from the sell side, can all come together to create value for our customers and benefit everyone. And that is the promise of FDC3 and the promise of network effects. So yeah, that is all I have for today. We still have a few minutes left, so if anyone has any questions, then I'd be happy to answer them. Anyone? I can't see the hands very well. Hi, yes, over there.
You talked about microservices, like for example, being decoupled and using HTTP to communicate with each other. But then you use the FDC3, for example, of the communication channel for the micro-frontends. Can you actually talk to the value proposition of FDC3 over HTTP and why that was chosen, and like what are the specific benefits that it offers?
Yeah, that's a great question. It's something we've talked about a lot recently in the FDC3 working groups in the community. Is how can we extend the value proposition? Can we make that connection maybe with HTTP that a lot of people are already comfortable using? There's some challenges to doing that in a desktop environment that we need to solve, but I think if we want to truly leverage those effects, it's something we have to think about. Yeah, the question is if we're reaching out to other parts of the community to bring more people on board with this way of working, and I think that's the true promise of such an approach, right? The more people we can get involved, the better we can expand the network and get the value out of it. I mentioned that we work closely with the financial objects group that are trying to define standardized ways to talk about orders and trades and various financial products in a standard way across the industry. So we're trying to mirror our contracts on that. But it really is a concept that spans across just one single desktop or beyond financial services. So it is just in its infancy, but we want to see where we can take this. And I think it's very heartening that the whole industry is coming together, recognizing that this is a shared problem and that we can all help each other. And that is being done in the open, in the community. Yeah. Yeah, hello?
Based on what I'm seeing, this has to be OS agnostic, right?
Sorry, I can't hear very well. Can you speak up a bit?
This has to be OS agnostic, correct?
Yes. The whole, just like HTTP or any other standard, it falls down a bit if it isn't agnostic. And what FDC3 is trying to uplift and abstract patterns that people have been using for a while, building financial desktop applications. Using some of the vendor products, people have been connecting applications together, but in non-standard ways. So we're trying to standardize those ways so that they are agnostic of who is involved. And we've got people from organizations like Thomson Reuters, IHS Markit coming to the FDC3 sessions, being involved in the community in the process. So we're trying to make it as broad as possible to achieve that.
And the second part is this a standard that you're building, or do you have any sample concepts?
We are quite careful that we don't want to provide a platform because then you lose a bit of the open standard nature. So we're trying to create standards and then people can try and implement them in their platforms and feed back what they find, and then we bring the standards further along. So we have samples of usage. We have some of the members of FDC3 who build applications that demonstrate how it can be used. Cool. One last question.
Hi. Have you guys considered use cases or defining standards that are more
Yeah, I think that is something that has come up. At the moment, it's relatively point-to-point, but you know, if you want to help us explore that, get involved in the community, we'd love to get proposals from people and continue that discussion, because that is definitely something that we want to consider. I'm slightly over, but just one more.
So regarding the app directories right now, you need to know the apps up front when you need to register them. Is there a way to facilitate dynamic registration of apps? So what I'm trying to say is apps that when they come online, they can register themselves as saying, okay, I can have a certain intent.
Yeah.
So you really can scale out your
The reason why the app registration is upfront is because it allows the application to be launched on demand if it isn't running, right? But I know some of the vendors who've implemented FDC3 have added dynamic registration to it. So it is available, it isn't in the standard currently. And the approach I think we're trying to follow now is, if you imagine how the browser vendors work, they run ahead of the standards and try things out, and then eventually the things come back into the standard and become standardized across everyone. So I think that's what we're trying to do now, because there's value in people experimenting and finding out the best way to do things. Cool, thank you very much everyone for attending, really appreciate it.